Hello world, welcome back to my channel Learn with Shivaji. Before starting today's video, if you are new to my channel and not yet subscribed to my channel, then subscribe it now and press the bell icon so that when I upload any new video, you get the notification first. So without any delay, let's start today's video. Today we are going to learn about equilibrium equation and its application in different type of structure. So before equilibrium equation, let's learn first what are the different type of structure in civil engineering. Structures are broadly classified into two types. First, plane frame or two-dimensional structure, and the second one, space frame or three-dimensional structure. Further, these structures are again subdivided into two types. Plane frame are of two types. First, pin jointed plane frame, and second one, rigid jointed plane frame. Similarly, space frame are also of two types. First one, pin jointed space frame, and second one, rigid jointed space frame. Let us first understand what is a pin jointed plane frame. Pin jointed plane frame are those in which all the joints are pinned or hinged in nature. Therefore, it is also called as pin jointed plane truss. As its name says, it is a two-dimensional truss system. The following are different representation of pin jointed plane frame, where it is shown that all joints are hinged. In this type of structure, horizontal, vertical or inclined load can act, but it must and should be placed at the joint. If we consider one single member in this structure, it can be seen that due to the external load, member of pin jointed plane frame develops only one internal force, and that is axial force. This axial force will pass through neutral axis, which is represented in dotted line. Therefore, it can be concluded that for a pin jointed plane frame or plane truss, all the joints are pin joint or hinge joint. Loads or forces will act only at the joints. Third one, due to the external load, only one internal force will develop in the structure, and that will be axial force. Last one, no shear force and bending moment will develop in the pin jointed plane frame structure. Next type is rigid jointed plane frame. Rigid jointed frame are those in which all the joints are rigid in nature. Rigid joint is the one which can transfer axial force as well as moment, and the angular distance between any two members connected to this joint will remain same in all loading condition. The following is the representation of a rigid jointed plane frame where the joints are marked as rigid. Unlike pin jointed plane frame, in this type of structure, the forces or loads can act not only at the joints but also at the member. Therefore, in a rigid jointed plane frame, each member may subject it to three internal forces consisting of an axial force, a shear force, and a bending moment. Finally, we can summarize that in a rigid jointed plane frame, all joints will be rigid in nature. Loads or force can act on both joints and at the members. Third one, due to the external load, every member in the structure will develop three internal forces, and those are shear force, bending moment, and axial force. Fourth one is rigid joint is not a fixed joint. The difference between rigid joint and fixed joint we'll learn in a different video. The next type of support is pin jointed space frame. It is a three-dimensional structure in which all members are connected by hinge. The following is the representation of it. It is having all the similar properties of pin jointed plane frame. The only difference is it is three-dimensional structure, whereas pin jointed plane frame is a two-dimensional structure. Now, the last type of structure is rigid jointed space frame. It is also a three-dimensional structure, but in this, members are connected by rigid joint. The following is the representation of a rigid jointed space frame. It is having similar properties of rigid jointed plane frame, but the only difference here is under the given loading, each member of this type of structure will develop 6 internal forces, and those are 2 shear force, 2 bending moment, 1 axial force, and 1 torsional moment. Now let us learn about equilibrium condition. First, what is an equilibrium condition? So, a body or a structure is said to be in equilibrium if the net force on that body or structure is 0. There are 2 types of forces which can act in a structure. First one, normal force, and second one, moment force, which sometimes act directly or sometimes occur due to the normal force. Therefore, it can be concluded that equilibrium equations deals with the balancing of forces in order to maintain stability. If equilibrium equations are not satisfied, then the structure will become unstable. Now let's see what are the different equilibrium equations available. First, case 1, equilibrium equation with respect to structure as a whole. In the left hand side, we'll write type of frame, and on the right side, number of equilibrium equation. So first one, plane frame, in which both pin jointed and rigid jointed frame are there. So number of equilibrium equation required for plane frame is 3, and those are sum of all forces in x direction equals to 0, sum of all forces in y direction equal to 0, and sum of moment about any joint is equal to 0. Now for second type of structure, that is for space frame structure, the number of equilibrium equation required for this type of structure is 6, and those are sum of all forces in x direction equals to 0, sum of all forces in y direction equals to 0, sum of all forces in z direction equals to 0, sum of all moments about x direction equals to 0, sum of all moment about y direction equals to 0, And finally, sum of all moment about z direction equals to 0. Now let's see number of equilibrium equation with respect to the joints. So left hand side we'll write type of joint, and in right side we'll write number of equilibrium equation. First one, pin jointed plane frame. The number of equilibrium equation for this is only 2, and those are sum of all forces in x direction equals to 0 and sum of all forces in y direction equals to 0. Coming to the second one, pin jointed space frame. Here, number of equilibrium equation required to maintain stability is 3, and those are sum of all forces in x direction equals to 0, sum of all forces in y direction equals to 0, and sum of all forces in z direction equals to 0. Now for third type, that is rigid jointed plane frame, here also we require 3 number of equilibrium equation to maintain stability, and those are sum of forces in x direction equals to 0, sum of forces in y direction equals to 0, and sum of moment about any joint is equals to 0. For the last one, that is rigid jointed space frame, in this 6 equation of equilibrium has to be satisfied to maintain its stability, and those are sum of all forces in x, y and z direction equals to 0, and sum of all moments in x, y and z direction equals to 0. So that's all for today. If you enjoyed the video, give it a thumbs up by hitting the like button. Share it with your friends and classmates. Comment down if you have any queries, and do not forget to subscribe my channel Learn with Shibaji and press the bell button. Thank you.